Okay, guys, we're moving towards the end of our semester here. We're going to look at 9.2 in this video. They just call it analysis, chemical analysis. I've always called it sequential chemical analysis because the steps that you follow and the sequence that you do them in is really important. So essentially what we're looking at here is if we've got a solution and we're not sure if it's this or if it's that, and we've got a couple of choices and we want to find out what it is, there's a way of testing it. So what we're going to look at is we're going to go to the solubility chart is what we use pretty regularly back on page 424, and that's what I just flipped to in the book. Excuse me. So we've got one. This is out of the textbook, but I'll do it with you. So we've got, in a common one, so we've got a leaky bottle of solution. And we're not sure what it is because the label's fallen off. That's kind of a common example. And we know that it may have lead-2 ions in it and or barium-2 ions. It may have one, it may have both, it may have neither. Okay, so we've got to figure out how we're going to be able to check for that. So what we're going to do is we're going to try and essentially make, if we add something to it and we get a precipitate, then we want to isolate, okay, well, that has barium or that is lead. But we want to have, so we want to look at something. Is there something we can add that would make lead precipitate or barium precipitate, but not both at the same time? Not in the first step anyway, because we got to isolate one first. So if we go to our solubility table and we could cheat and look at the book, but what do we have as exceptions? So things that have the exceptions for solubility, right? If we go up Ag, well, we've got one. So we've got a chloride and other halides. Lead-2 is an exception. So that's a possibility. So the other thing we got to check then, so long as barium is not also a possibility, then that's one we could use. Okay, and barium is not one of those. So we could use something chloride or any of the other halides, so an iodide, a phosphide, any of those. Generally, we use one that is kind of most readily available. The next one, if we look at the sulfates, we see that barium, in that particular one, barium is an exception, so that would give you a precipitate, but lead-2 is also an exception in the sulfate. So you can't add something sulfate to start because you can't tell if you've got barium or lead precipitate. So we can use those two substances. We're going to use a chloride or a halide, and we're going to use a sulfate because those are where our exceptions are, but we can't use the sulfate first because then we can't tell which one. So I'm going to use, I think the book uses like an iodide. I'm just going to make it simple. You can use whatever joins to it. So what we're going to say is here, we're going to add sodium chloride, right? Sodium chloride's a good one. The book uses, I think, potassium iodide. Either of those is fine. So there's no exceptions to it with the sodium. That's the other thing. You don't want to create something that will have a precipitate. So if we get it, so what's going to happen here is that if we've got those lead ions in there, right, we're going to get lead-2 chloride. And lead-2 chloride is going to give you a precipitate. So if you get PbCl2, if a precipitate forms, which means Pb plus 2 is present. On this side, pretty simple. No precipitate, then you have no Pb plus 2 ions. Okay? So if you add that and you get a precipitate, then you know. Now the other part would be whatever it is. Remember, sodium, and the reason we use sodium is a good one. we want to use sodium and potassium as much as possible as our cation part here. So the chart gives you which ones give you the exceptions with your anion, but if you use sodium, potassium, you look at your chart, sodium and potassium, there are no exceptions. They're all soluble. So always use sodium something or potassium something, right? If you just use sodium something every single time, then you're always going to be fine, okay? So now the second step is if we come back together here, both sides, now I have to figure out if there was PbCl, if there was lead ions in there, we've precipitated them, we removed them, and now what's remaining is we've got to determine, is there barium in there as well? So remember, barium we determined by the chart, the exception to it is a sulfate, so let's add, I just like to use sodium all the time. Let's add sodium sulfate solution, and the same thing is true. If you get a precipitate, means BaSO4 is produced. You've got Ba plus 2 AQ present. On this side, same thing, no precipitate means no Ba plus 2 AQ are present. Okay, and that's it. That's sequential chemical analysis. So this is if there's just two, and most of the time we're just going to see two pieces into it. But so the key is, number one, find the exceptions that will cause a precipitate. And then as you the reason I always call it sequential is because the sequence is important. Yes, we're going to use sodium sulfate and sodium chloride in this example, but if you use sodium sulfate first, your answer is not going to be correct. This may be true, but then we can't tell if this one is true because you could precipitate both of them at the same time. So you want to pick something that only precipitates one of the things you're looking for, one at a time, right? And even though sulfate would precipitate out Pb plus 2, we've already removed it. So because NaCl only precipitates this one, once it does, we can take care of it, and then we can use the sulfate after. Okay, so that's sequential analysis. Now, that's the easiest way to do it. But when we have things like if we're looking for is sodium present, is copper present, is this present? Sometimes the other one, I'm sure you did it, most of you before, you do the flame test where you put a particular solution or a particular metal into a flame and the flame changes color. Anytime you use copper 2 sulfate solution, copper chloride solution, pure copper, put it in a flame, it's going to turn green. So a green flame means copper is present. So a flame test is another way we can do it. And then the last way is we've got a nice, really fancy device that you can use now, and it's called spectroscopy, which means we're going to analyze the light that is produced and the wavelength of light, and then we match it up to specific ones. So it's very, very specific, but it's a little more complicated to do, and you need some expensive machinery. But those are all in the book. Just take a quick look at the notes on those, and we'll be all good. Okay, so that's 9.2. And then we'll finish up chapter 10 next week, and that'll be it. So look forward to the next video. I'm going to do 9.4, 9.5, I think, today as well. Okay, so good luck with this one.